The escape velocity from the Earth's surface is v. The escape velocity from the surface of another planet having a radius 4 times that of Earth and same mass density is. Options are given 4v, v, 2v and 3v. It's a previous year question from NEET 2021. It's a topic from the topic gravitation. I hope all of you heard about escape velocity. Escape velocity means the minimum velocity that we have to give for a body to escape from the gravitation field of a planet. You know that when you are on the planet, the Earth is pulling towards the center. So if you want to completely escape out of that gravitation force of attraction, we have to give certain amount of kinetic energy. How much is that kinetic energy? See, if you know that value, and if you are projecting a body towards outer space with that velocity, the body will be permanently escaping from the surface of Earth. That is the idea. See, this can be easily proved with the help of conservation of energy. Assume that you are on the surface of a planet. See, assume that you are on the surface of a planet. Assume this planet is having mass m, okay, maybe Earth, and radius is r, and on the surface of that planet another mass, small mass m is resting. Assume that now you are going to project with a velocity ve, okay. So the initial energy we can calculate. The total energy is going to be equal to kinetic energy plus potential energy. So we can say initial kinetic energy, let it be half mve square, okay. Now what is the potential energy? Potential energy is minus of gmm by r, okay. So potential energy is minus of gmm by r, because when the bodies are attracting, the potential energy is defined as negative of gmm by r. Fine, this is the initial energy. Initial total energy, we can say total energy before starting, or just at the beginning of the launch, we can say that half mv square minus gmm by r is a total energy. This should be equal to, assume that the body is now reaching outer space. When you reach this outer space, we can say that the velocity becomes negligibly small. That means velocity goes to 0, the kinetic energy goes to 0. Same way, gmm by r, when r tends to infinity, we can say 1 by infinity is 0. So we can say that final energy becomes 0. So this is the key logic behind escape velocity derivation. So both kinetic energy as well as potential energy goes to 0 when you go to the final condition. So this is the logic we have to apply here. Fine. Now if that is the case, we can equate this. See, from here we can find out the expression. So half m ve square should be equal to gmm by r. See, look here, we can easily cancel out this mass. Small mass we can cancel out. It doesn't have any role. So that is the idea. When you are launching a rocket, it doesn't matter how much mass is there. If you are giving that much velocity, it will escape from the surface of Earth. Fine. So from here we'll get v is equal to under root of 2 gm by r. That is the expression which we need in this problem. So ve is equal to root of 2 gm by r. Fine. In this question, we know the in our case the mass is the radius is 4 times. Given that the radius is 4 times, let us see how to do this. First of all, you know that density. What is density? The mass density is defined as mass by volume. Volume of a sphere. How much is the volume of a sphere? 4 by 3 pi r cube. Fine. See, we can substitute for mass. Instead of mass, we can give that, because given that the second planet is also having same density. So escape velocity expression we can generalize. Escape velocity is going to equal to root of 2g. What is m? Instead of mass, we can substitute 4 by 3 pi r cube multiplied by density divided by radius. You can see that. See, all values are constant. See, 4 by 3 pi constant, rho is constant, g is constant, 2 is constant, r cube by r, how much is that? R square. Or we can say that ve is proportional to root of r square, or ve is proportional to r. So this equation we need to solve that problem. So now let us go to the problem. So, initial velocity v is proportional to r on the surface of earth. Fine. Then v dash is proportional to 4 times radius. You can take the ratio. You know that here v by v dash is going to be equal to escape velocity, okay, is equal to r divided by 4r. Okay, here we can cancel out this r, and how much you'll get? V dash is going to be equal to, so in this case, v dash is going to equal to 4 times ve or v escape. So this is the answer. So in this case, it is going to be 4 times. Which option is correct here? So first option is correct. I hope all of you understood this problem.